Hello, Mrs. Wagner here. Just wanted to go through lesson 6 with you and kind of talk to you about what criteria and constraints are. So, this is your lesson 6 notebook. This is the last lesson for our water cycle unit. Okay, so lesson 2, this is called Finding, or lesson 6, this is called Finding Successful Solutions. So, we're going to kind of work on what it means to find a successful solution and how we can go about it in a systematic way, which just means that you have a system of working out a problem. Okay, so this is just a little example. My rich uncle is so impressed with the work you are doing for the Planning Commission, he wants to treat our class to pizza from any restaurant that will deliver to the school. As a class, we just need to pick the best pizza restaurant that will deliver to our school during your lunch period. So, what exactly is the problem that we need to solve? Okay, so let's just take a look at this scenario. Somebody wants to buy us pizza. We want it delivered to the school, and our class is probably 25 students. So, the problem that we need to solve has something to do with the pizza place. So, we know that our lunch period is right around 10:15. Okay? It's early, right? It's kind of early for a lot of restaurants. Um, so, is that a problem? Could that be a problem that we would need to solve? There are about 25 students in the class. Everybody has different tastes, right? Um, and we have kind of a wide variety of tastes. So, narrowing pizza down to what we might like, could that be a problem? What about things that we might come across like different crust flavors? Do we need to decide what kind of crust we would want? Would we want a thin crust, a thick crust? So that might be a problem. Um, I would imagine we would want hot pizza. So finding a pizza place sort of close to the school. So when the pizza arrives, it's hot. So maybe that could be a problem. Okay, so just kind of think about those things. And then in this slide, you're going to type in what is the problem that we need to solve. Okay, based on kind of what I talked about. You can also pause the video, rewind the video if you need to listen again to get your answer typed out. All right, slide 4. Okay, so let's talk about these questions. How would we know if we identified a successful solution? How would we know that? What is the difference between constraints and criteria? Okay, so when it says see video, this is the video. Okay, so if you're opening up this notebook, you are listening to a video that's going to go through. I'm going to talk about constraints and criteria. Okay, so let's start with criteria. So, criteria, these are the things that we have decided. So, for example, with the pizza place, criteria are the things that we have decided are important to us. Okay. So we want to make sure that the pizza is hot. That is important to us. It's something that we would want in our selection. Maybe we want a flavored crust. So we would want to find a pizza place that serves flavored crust because everybody likes garlic crust. So we would want to find a pizza place that serves garlic crust. That's a criteria for our decision. We want to make sure that the pizza place serves the toppings that we want. Okay. It doesn't prevent us from picking that particular pizza place, but it's a criteria that we have when we choose the pizza place. Okay. So, again, criteria are the things when we're choosing or solving or making a solution. Criteria are the things that we want to happen in our choice when we choose something. Constraints would be something that we have to have it. It has to be that way. For example, and it's not something that's negotiable. And it could prevent us from picking a particular pizza place. For example, um, our lunch period is 10:15. So a constraint would be a pizza place that does not open at 10:15. So that's a constraint. We could not pick a pizza place that is open at 12. We would not be able to pick that place. So the time at which we need the pizza is a constraint. All right. If they don't deliver, then that's not a pizza place we could pick. So that's a constraint. So constraints are things that would stop us from making that particular solution. Okay. So my daughter's car broke down and she's in the process of getting a new car. And here are some examples of criteria for her. Okay. The criteria is she would like it to be a 2015 or newer car. Criteria number two, the mileage on the car needs to be less than 100,000 miles on the car. Criteria for her, number three, is it needs to have a rear view camera. So those are three criterias when picking a car. She has listed 2015 or newer, no more than 100,000 miles on the car, and a rear view camera. Another criteria might be something like uh, power windows, or if somebody wanted leather seats, that would be criteria. Okay, now a constraint, something that would prevent her from buying a particular car, might be cost. If it's beyond her budget, then she can't pick that car. So her budget, let's say, is $250 a month for a monthly payment. If the car is $350 a month, then that's going to prevent her from buying that car. So constraint number one for her would be cost. So the cost of the car, it cannot be above a certain number for her budget. Okay. Constraint number two would be safety. So if it has a low safety rating, then she cannot buy the car because it's not a criteria. It's not something she wants in the car. It's a constraint because of the importance placed on that part of the solution. So safety would be constraint number two. So safety rating would be a constraint. Okay. Another constraint might be location of the car dealership. All right, that might be a constraint. If it's too far away, she can't get to the car place, then that would be a constraint. Okay, so criteria are things that we have listed that we would like to have. Constraints would be something that would prevent us from picking that particular solution. Okay, so number three, how could criteria and constraints help us solve the problem? First, we would want to list the criteria. Okay, what are the things that we want to have in the solution? So we list those criteria. And then when we come across a particular solution, we look at our list of criteria. Do they fit the criteria? And then the constraints. What are things that would prevent us from picking that solution? Cost. Usually, when you're making a solution, cost seems to be a big thing. So, cost could be a constraint. So, we could list our constraints. Okay. And if it doesn't match the constraint, if it goes above the constraint, then we cannot pick that particular solution. Okay, so let's take a look at our pizza situation. So we have our pizza place. We found a pizza place. The code is pizza. So carefully read this user information website information on Codis Pizza. And we'll use this information to answer our questions, which are first our criteria, and then we'll go through the constraints. So, as a class, we decided that we want the pizza delivered hot. We decided one of our criteria is that we're going to have crispy crust, and we would like flavored crusts. Okay, those are criteria. So we look at the pizza place. Okay, here's a pizza place. Hours are Monday through Thursday, 3 p.m. to 9 p.m., and Friday through Sunday, 3 p.m. to 11 p.m. So you get all the information you can about this pizza place. And here's what a review said about it. I love Coda's Pizza. They deliver right to my house, and the pizza is so hot it burns my mouth. The crust is so crispy, it crackles when you take a bite. Plus, they have 5 flavors of crust. Okay, so we look at the criteria that we have set up. Based on this information, we can choose if it fits the criteria or not. So pizza delivered, uh, our pizzas need to be delivered hot. So we would rate it. So with criteria, again, this would be something that you could rate. And then if you want to go back up into slide number 4 and add this to your answer, criteria are things that we would be able to rate, okay? So the pizza is delivered hot. Okay. So if it comes warm but not steaming, we might rate it a 1. If it's hot but doesn't burn the mouth, we would rate it a 2. But our highest rating would be hot enough to burn my mouth. So using this information above, what would we highlight pizza delivered hot based on this information? A 1, a 2, or a 3? All right, for crispy crust, we would give it a number 1 if it's mushy but we cannot feel or hear the crust. We would give it a 2 if it's crisp but does not make a sound when bitten. And right, number 3, we would rate it a 3 if it's super crisp but makes a crunchy sound. Flavored crusts, um, we would rate a pizza place if it has 1 to 3 flavors. We would a 1. We would rate a pizza place a 2 if it is 4 to 6 flavors, or if the pizza place offers 6 plus flavors, we would give it a rating of 3. So highlight what we would rate each of these criteria: a 1, a 2, or a 3. And so at that point, you would give it a number. You would add up your ratings, okay? Um, and if it has a high rating, then we would say, okay, this might be a good place to order pizza. Okay, so criteria are things that you choose what you want for your particular solution, and then you can rate them. And the higher rating would be the better place to get pizza. All right, so let's talk about the constraints. So looking at our, chart down here, our constraint would be the place has to serve pizza, it has to deliver, and it has to open during lunchtime. And constraints would be yes or no. You don't rate them, it's either a yes or a no. And if you have any no's, you cannot use this pizza place. Okay, so does the pizza place serve pizza? Yes or no? Does it deliver? Yes or no? Is it open during lunchtime? Yes or no? Okay, so again, if any of the constraints have a no, you cannot use this solution. So could Coda's Pizza be a successful solution? Why or why not? It may have a high rating. It may have a good enough rating. But if it is any no in the constraints, if we have put an X in any of the no's, then we cannot use this solution. Okay? So we would say no, this is not a good solution. And the reason would be it does not meet all of our constraints. So you need to go back up and look at the information here and look at the information in the review and decide, does it meet all the constraints? And if not, You have to say this is not going to work, no, and then decide or not decide or explain why it does not meet the um, why would it not be a successful solution. Okay. All right. So then slide 7, let's decide what the land should be. It's time to decide what the land should be. Okay. So we're going to use criteria and constraints to try and figure out what this land should be. So let's review, let's go back. What was our challenge? A planning committee has hired us to figure out what is causing the stream to flood. So that was the first thing they hired us to do. So, what did we find out about that? All right, we found out a lot of things about how fast water moves towards a stream versus what causes water to move slowly towards a stream. Okay, when it was a forest, we learned that it was a slow pathway of water to the stream. Why was that? When the building was built and torn down and a parking lot was on one side of the stream, we learned that there was a faster pathway of water to the stream, which was causing it to flood. What was causing that faster pathway of water? What was causing water to go more quickly to the stream? Okay. Number 2, the owner of the land will donate it to the community. But why? And what would cause the owner to donate it to the community? What and who does the owner want to make sure the land will help? Okay. So what do we want to fix? What do we need to make sure that when we change the land and what we decide the land should be, what should that benefit and who should it benefit? Okay, the landowner will say, yep, I'll give the land to the community because you have created a solution that will benefit the environment. And then who will it also benefit? All right. So then slide number 8. Let's talk about this question. Think about what changes did humans make and how did it affect the amount of water in the stream? Now, what changes did we make? Well, we tore down a forest and built a building and a parking lot. Those were changes. So, how did it affect the amount of water in the stream? Okay, so the question is how can we convince the planning committee that changing the land surface in this particular watershed, the park, will influence flooding? So we're going to make another change. Okay, how is that going to affect the flooding of the stream? Will it help the flooding? How will our change as humans affect the flooding? Will it affect it in a positive way? Will it affect it in a negative way? So, things that we need to think about in how water moves. So, I need to show the planning committee how the movement of water was affected by humans. I can do this by number 1, we need to fill in the blanks, explaining that 2 things need to increase to remove water from the system into the air. What are the 2 things that we learned about how we can get water to go into the atmosphere? How does water move from the surface of the soil or the surface of the earth? How can we get it to move up into the atmosphere? What would we need? Remember the driver of how water goes from the earth to the atmosphere, okay? And then what could we do as humans? How could we change the environment? How could we change the area that allows more water to go into the atmosphere? Because that's one thing we want to do is remove water from the area and get it to go into the atmosphere. So what could we do as humans to the area to get it more water to go into the atmosphere? Number 2, what would we want to increase to slow down the entry of water into the stream? What was a slower pathway of water going into the stream? Okay, so water needed to do something. First, go into the atmosphere, which would be number one. And then in number two, we want water to go somewhere else. That's a slower pathway. So, what's that vocabulary term there? That would cause water to go somewhere else. Remember, one of the drivers to get water to go somewhere else, which would be a slower pathway to the stream. And then think about a faster pathway, and we want to decrease that. So, a faster pathway into the stream is something we would want to decrease. So, decreasing what? One of the vocab terms, okay, to slow the rate of water into the stream and then filter the water that gets into the stream. Okay, so we want to decrease this one. We want to increase something about water moving to the stream because it's a slower pathway. We want to decrease how the water gets to the stream because in this situation, it would be a faster pathway. So maybe you need to go back into lesson 2 or lesson 3 and look at your uh, models again. What were the slower pathways? What were the faster pathways? Okay, so on the next slide, we're going to talk about four different pathways, not pathways, four different solutions, okay, on what we could do with the land. Okay, so the planning committee said, all right, we've narrowed it down to these four different options. So we're going to investigate these options. They said a soccer field, a playground, a water park, but on the water park, on the roof of it, we will do a green planting roof. Okay, and a then fourth option would be a rain garden. All right, so let's remember we've got some criteria that we're going to look at, and we have some constraints, and we're going to look at what the planning committee has decided are the criteria and what are the constraints. So now we have to review those. All right. Okay, so I know you can't see this very well, but this is what your task cards in Google Classroom will look like. You will have another instructional video of these going over these task cards in Google Classroom. Okay, so the example of the task card is going to be that we're looking at the particular proposal. So this development option or proposal is a soccer field that would replace the parking lot. So not the field, but the parking lot side, okay, would be a soccer field. All right, think about what's on the parking lot and what replacing that would be with a soccer field and how that would change the land and how that would affect how water moves into the stream. Okay, so it says that the parking lot side will be completely converted into a soccer field that can be used by the community. The new land surface will be nearly all grass with small areas for gravel for parking. So the parking would be not concrete, but gravel. And how will that change how water moves? All right, so the parking lot replacement, the project costs, I think that says like $400,000. The environmental impact, we've got some bullet points on how it impacts the environment, how it impacts the community socially, and the economic impacts. So we'll take a look at four different cards with all of those things. But this one is the soccer field. Okay, so these are kind of the requirements, maybe some of the criteria. There might be a constraint, so we're going to take a look at those. But this is what our task cards look like. Okay, so you don't need to do anything on this slide. On slide 11, we're going to go to Google Classroom. So in your next assignment, you're going to go to Google Classroom and we're going to go through all these four scenario cards for ideas that will either replace the parking lot or the field. So we'll read through each of the scenarios. We'll use criteria and constraint checklists, much like we did with the pizza place, to evaluate our assigned scenario. And then we'll kind of share out at some point. Okay? All right. So get this slide deck done. And then in your next assignment, you will, with the task cards, you will have another instructional video that will take you through all of that assignment. Email me if you have questions.